Hello students, today we are going to discuss JEE Advanced 2026 Physics Paper 2. The first question, a metal wire of cross-sectional area 0.5 millimeter square and length 100 meter is connected across a battery of EMF 2 volts and internal resistance 1 ohm. The density, atomic mass and electrical conductivity of the metals are 6.35 into 10 power 3 kg per cubic meter, 63.5 gram per mole and 2 into 10 power 8 mho per meter respectively. Assuming one conduction electron per atom of the metal, the drift velocity in millimeter per second of the electrons in the wire is dashed. Avogadro number is given, which is 6 into 10 power 23, and charge of the electron is 1.6 into 10 power minus 19. So, when you want to calculate the drift velocity, we need to know the current in the conductor. So, to find out the current in the conductor, we will calculate resistance of the conductor. Because conductivity is given, length is given, area of cross section is given, resistance is given by R is equals to L divided by sigma A. Length is given as 100 meters, sigma value is given as 2 into 10 to the power of 8, area of cross section is 0.5 millimeter square, 0.5 into 10 to the power of minus 6. So, this resistance is found to be 1 ohm. So, if this is the conductor, it is connected to a cell. EMF of the cell is E, internal resistance is small r. Resistance of this particular conductor is R. The current in the conductor is equals to I. So, if you want to find out the current in the conductor is EMF divided by total resistance. EMF is 2 volts, internal resistance is 1 ohm and resistance of the conductor is also 1 ohm. So, the current will becomes equals to 1 ampere. Now, to find out the drift velocity, we need to calculate number of free electrons per unit volume. Because it is given in the question that each metal atom will contribute 1 free electron, let us calculate the number of metal atoms per unit volume. So, how do you calculate this one? Density is given. So, when density is given, density is equals to mass of the metal per unit volume. Mass of the metal can be written as mass of each atom into total number of atoms per unit volume. So, from this equation I can find out number of atoms per unit volume, which is density divided by mass of each atom. That should becomes equals to density divided by mass of each atom. How do you calculate? So, because molar mass is given, mass of each atom is molar mass divided by Avogadro number. So, Avogadro number goes to numerator. So, the free electron density or number of atoms per unit volume both are equal. That should becomes equals to density is given 6.35 into 10 to the power of 3. Avogadro number is given 6 into 10 to the power of 23 whole divided by molar mass is given as 63.5 gram per mole. So, I convert that one to kg per mole. 63.5 into 10 to the power of minus 3. So, now from this equation, this is 0.1 time, this value will becomes equals to 6 into 10 to the power of 28 per cubic meter. Once we got the free electron density, once we got current, we can find out drift velocity. So, drift velocity is calculated like this. Drift velocity is equals to current I divided by NEA. Current we got as 1 ampere, N we got as 6 into 10 to the power of 28 and charge of the electron is 1.6 into 10 to the power of minus 19 and area of cross section is 0.5 into 10 to the power of minus 6. Drift velocity equals to 1 divided by 6 into 0.8, that should becomes equals to 4.8 into 10 to the power of 28, 10 to the power of minus 19, 10 to the power of minus 6. So, you are going to get 10 to the power of 3 in the denominator. This value is equals to 10 to the power of 3 divided by 4.8, which is nothing but 0.208 into 10 to the power of minus 3 meter per second. So, this should be option C. Second question. A nuclear reactor starts producing a radioactive nuclide X from T equal to 0 at a constant rate alpha per second. Each decay of X produces energy E naught, which is utilized to heat a liquid of mass m and specific heat S. Assuming no heat loss from the liquid and taking lambda as a decay constant of X, the rate of increase in the temperature of the liquid is dash. So, whatever the energy that has been evolved during the nuclear production, that is utilized for heating the liquid. So, first of all, let us see how much of energy, how much of the power is generated during the decay process of X. So, to find out the power generated during decay process of X, we have to know the number of nuclei that are undergoing decay per second. We should know the activity of the nuclei X. So, to find out the activity of nuclei X, we have to calculate the number of nuclei at any instant of time. So, how do we calculate? So, here simultaneously this nucleus is produced as well as what? Decay. So, the equation what? Let us imagine that at t equals 0, there are no nuclei at an instant of time t. At time t, dN by dt is the rate at which number of nuclei is changing. The rate of production is given as alpha. The rate of decay is nothing but equals to lambda into n. So, now from this equation I can say dN divided by alpha minus lambda n is equals to dt. Now, what we do is we will integrate this equation on both the sides. When we integrate this equation on both the sides, we are going to get integral dN divided by alpha minus lambda n is equals to integral dt. At t equal to 0, there was no nuclei. At an instant of time t, let us imagine that the number of nuclei are n. Integral dN divided by alpha minus lambda n can be written as minus 1 divided by lambda into ln of alpha minus lambda n between the limits 0 to n is equals to t. Applying the limits here, minus 1 divided by lambda into ln alpha minus lambda n divided by alpha is equals to t. So, from this equation I can say alpha minus lambda n by alpha is equals to e to the power of minus lambda t. So, from this equation we are going to get n is equals to alpha divided by lambda into 1 minus e to the power of minus lambda t. This is going to be the number of nuclei at an instant of time t. Once we got the number of nuclei at an instant of time t, what we can do is we can find out its activity, that is number of nuclei undergoing disintegration per unit time. So, from this equation I can say the activity is equals to lambda n, that should becomes equals to alpha into 1 minus e to the power of minus alpha lambda t. What will this will give? This will give number of nuclei undergoing disintegration per unit time. So, because here they said that it will produces energy E naught, each decay will produce energy E naught, and here this will give number of nuclei undergoing disintegration per unit time. The power generated will becomes equals to the activity into E naught, and this is utilized for heating the substance liquid. So, the amount of power required for heating the substance, let us imagine that the rate at which the temperature is changing is nothing but d capital T by dt. So, this can be written as ms dt by dt. This implies alpha E naught into 1 minus e to the power of minus lambda t is equals to ms into dt by dt. So, in the question they say rate of increase of temperature of the liquid. The rate of increase of temperature of the liquid will be given by dt by dt is equals to alpha E naught whole divided by ms into 1 minus e to the power of minus lambda t. This is the rate at which temperature is changing. So, according to this question, this should be option A. Next, we will go to the third question. So, this is the third question where they have given a varying refractive index question. A beam of polychromatic light passes through a thin prism of a prism angle 6 degrees. The refractive index of the material of the prism varies with a wavelength lambda as n lambda is equals to a lambda plus beta by lambda square, where alpha is 3 micro per meter, 3 micrometer inverse, beta equals to 0.096 micrometer square. If lambda minimum is a wavelength at which the angle of minimum deviation delta m is smallest, then the correct value of dm at a lambda minimum is dash. So, they are asking like under what condition this deviation is going to be the minimum deviation is going to be least. So, obviously, the deviation produced will depends on refractive index and angle of the prism. So, the deviation produced at any instant will be given by delta d equals to mu minus 1 into a. So, according to the question, d is equals to the value of mu is given as mu or n both are same, which is nothing but alpha lambda plus beta by lambda square minus 1 into a. So, we can see that here d is a function of lambda. So, first of all we will calculate for what value of lambda this value of d will be minimum. So, if d should be minimum, its derivative with respect to lambda should be 0. So, differentiating this equation with respect to lambda, dd divided by d lambda will becomes equals to alpha minus 2 beta divided by lambda cube. Derivative of 1 will be 0 into a should becomes equal to 0. Now, from this equation I can say alpha should becomes equals to 2 beta divided by lambda cube is equals to 2 beta divided by alpha. So, lambda will becomes equals to 2 beta divided by alpha whole to the power of 1 by 3. So, lambda will becomes equals to 2 into the value of beta is given as 0.096 whole divided by alpha is given as 3 whole to the power of 1 by 3. So, from this equation we are going to get this value as 0.032. So, this will be 0.064 whole to the power of 1 by 3. So, lambda will becomes equals to 0.4 micrometer. For this value of lambda, what happens? The value of deviation is going to be minimum. So, when you want to find a minimum deviation, you need to substitute this value of lambda as 0.4 micrometers. So, let us calculate that minimum deviation. So, deviation is nothing but equals to alpha lambda plus beta by lambda square minus 1 into a. D is equals to, if this should be minimum, already we have calculated the value of lambda for which this deviation is minimum. We got a value of lambda as 0.4 micrometers. So, alpha value is given 3 into 0.4 plus beta value is 0.096 whole divided by lambda value is 0.4 whole square minus 1 into angle of prism is given as 6 degrees. So, let us evaluate this one. Minimum deviation will becomes equals to 1.2, this value the first term, plus the next term is 0.096 divided by 0.16 minus 1 into 6. So, d minimum will becomes equals to, from this equation, 1.2 plus 0.096 divided by 0.16, it will become 0.6 minus 1 into 6. So, d minimum will becomes equals to 1.8 minus 1, 0.8 into 6, that should becomes equals to 4.8 degrees. It should be option B. The next question, fourth question. A particle of mass m and angular momentum L is moving in a circular orbit of radius r0 under the influence of an attractive force f bar r is equals to minus k by r square into r cap. Keeping the angular momentum unchanged, the particle is displaced radially by a small distance delta r, which is very much smaller than r0, due to which its radial distance varies periodically. The corresponding time period is dash. So, here the particle is moving in a circular path initially in a stable circular path. So here the force, what is providing the centripetal force? A attractive force which is given by k by r square. It is directed towards the center, is providing the necessary centripetal force. So in a stable orbit, initially the necessary centripetal force mv0 square by r naught is provided by the attractive force, which is nothing but k divided by r naught square. So here this r naught and r naught will get cancelled. So from this equation we can say mv0 square r naught is equals to k. This is the first equation. Apart from that, he says that the angular momentum is conserved. So the angular momentum is given as L. So the angular momentum can also be written as L is equals to mv0 r naught. That should becomes equals to, when we change the orbit of this one, let us imagine that the radius has changed to r, and then let us imagine that the velocity has changed to v. So I can write this equation. Let us imagine that displacement away from the center is x. So this value will becomes equals to mv into r naught plus x. Now from these equations, what we can do is we can find out expression for r naught. This is equation 2. Now from 1 into m v naught can be written as L divided by m r naught whole square into r naught is equals to k. So what happens is, one r naught will get cancelled. So from this equation I can say m L square whole divided by m square r naught square into r naught is equals to k. One m got cancelled, one r naught got cancelled. So from this equation r naught will becomes equals to L square divided by mk. Okay. Now here what we are doing is we are displacing the particle from the stable equilibrium position, we are displacing it away from the center. So during this process, let us imagine that radius has changed from r naught to r naught plus x. So what happens is the force acting on it will change. In the rotating frame there are two forces that are acting. One is the attractive force directed toward the center, next one is the centrifugal force acting away from the center. So at displaced position, when we calculate the net force, so here I am calculating at displaced position net force is equals to, displacement is away from the center, the forces away from the center are positive, the forces toward the center are negative. So the force toward the center is nothing but minus k divided by, now the new radius is r naught plus x whole square is x, and the force directed away from the center is positive, that is centripetal force, which is nothing but mv square divided by radius is r naught plus x. So let us simplify this particular equation. So how do you simplify this equation? I need to replace this value of v. So how do I do this one? So net force will becomes equals to minus k whole divided by, from this equation I can say r naught square common, 1 plus x divided by r naught whole square plus m v. From the earlier equation we can write v as v naught small r divided by v naught r naught whole divided by r. Okay. So by r is nothing but r naught plus x. So here we are going to get this one square divided by r naught plus x whole cube we will get. Did you understand? Now from this equation I can say net force is equals to minus k whole divided by r naught square into 1 plus x divided by r naught whole square plus m v naught square r naught square whole divided by r naught cube if I take common, 1 plus x divided by r naught whole cube, right. R naught square will get cancelled. Now we will write everything in terms of L. So from this equation I can say net force will becomes equals to minus k whole divided by r naught square into 1 plus x divided by r naught whole square plus mv naught can be written in terms of angular momentum L. So what I will do is I will multiply this particular equation in terms of angular momentum. I will write what I can do is I can write like this. Since I will write here L is equals to m V naught into R naught. So, from this equation I can say V naught will becomes equals to L divided by m R naught. So, from this equation we are going to get this one as m into V naught square can be written as L square whole divided by m square into R naught square. You will get R naught square into R naught is R naught cube into 1 plus x divided by R naught whole cube. 1m and 1m will get cancelled. Now, already I have got a relation between R naught and k. So, when it comes to relation between R naught and k, we can see in the earlier slide R naught is equals to L square divided by mk. Okay. So, from this equation I can say net force is, the next slide, we will go to the next slide. Net force is equals to minus k by R naught square into 1 plus x divided by R naught whole square plus L square by m into R naught square. R naught is nothing but L square divided by mk into 1 plus x divided by R naught whole cube. Okay. Now, from this equation we can say net force will becomes equals to minus k divided by R naught square into 1 plus x divided by R naught whole square plus L square whole divided by m L power 4 by m square k square into 1 plus x divided by R naught whole square. Now, in this equation this m and this m will get cancelled, 1 L square and 1 L square will get cancelled. Here also I can say net force is equals to minus k divided by R naught square. What is the R naught square can be replaced as L square divided by mk. L square divided by mk whole square into 1 plus x divided by R naught whole square plus, here one L square will get cancelled from this equation. We are going to get this value as mk square by L square into 1 plus x divided by R naught whole square. Okay. Now, from this equation we are going to get this value as, let us simplify this equation. This m goes to numerator, net force will becomes equals to, so we got expression for net force. Now, let us simplify this equation by substituting the value of R naught. So, already in the earlier expression we got R naught is equals to L square divided by mk. So, net force will becomes equals to minus k by R naught square into 1 plus x by R naught whole square plus L square by m R naught cube into 1 plus x by R naught whole cube. So, already since R naught we got as L square divided by mk, net force will becomes equals to minus k whole divided by L square divided by mk whole square into 1 plus x divided by R naught whole square plus L square divided by m into L square divided by mk whole cube into 1 plus x divided by r naught whole cube. Now, let us simplify this equation. So, from this equation we are going to get net force will becomes equals to minus m square k cube divided by L power 4 into 1 plus x divided by r naught whole square plus L square m cube k cube divided by m L power 6 into 1 plus x divided by r naught whole cube. Now, let us cancel the common terms here. Here when we cancel the common terms, here L square will get cancelled, 1m and 1m will get cancelled. So, from this equation we are going to get net force is equals to minus m square k cube whole divided by L power 4 into 1 plus x divided by r naught whole to the power of minus 2 plus m k cube divided by L power 4 into 1 plus x divided by r naught whole to the power of minus 3. Because they are given that x is very much smaller than r naught, by binomial approximation we can say net force will becomes equals to minus m square k cube whole divided by L power 4 into 1 minus 2x divided by r naught plus m k cube whole divided by L power 4 into 1 minus 3x divided by r naught. So, m square k cube divided by L power 4 if I take common, this minus 1, this plus 1 will get cancelled, and here we are having plus 2x and we have minus x. So, we are going to get net force should becomes equals to m square k cube divided by L power 4 into x divided by r naught. So, again here in place of r naught we can write it as L square divided by mk. L square, we will write one more step, x divided by r naught with a minus sign, and r naught can be written as L square divided by mk. So, from this if you calculate the acceleration, we are going to get acceleration is equals to dividing with mass, we are going to get this value as minus m square k to the power of 4 whole divided by L power 6 into x. The value of omega is equals to m k square divided by L cube. Once we got this value of omega, we can find out the time period, and we will get the time period as 2 pi into L cube divided by mk. So, this will complete the first section of paper 2. We will move into the second section. Yeah, coming to section 2, this is the first question, section 2. It says that consider two isosceles prisms 1 and 2 with prism angles A1 and A2 and refractive indices N1 and N2 respectively as shown in the figure. The faces A1 B1 and A2 B2 are parallel to each other and perpendicular to the mirror M. If a ray of light is incident on the face A1 C1 and emerges from the face A2 C2, the correct statement or statements is R dash. So, here 4 options are given. Let us verify each option at a time. So, if you look at the diagram, there are two prisms, the angles of the prisms are A1 and A2. Now, they are inclined and they are almost symmetric to the mirror. So, a ray of light is incident on the first prism, refracted to the first prism, undergoes reflection by the mirror and then undergoes refraction to the other prism. Right, let us see each option at a time. If both the prisms are in minimum deviation condition, then they are asking what is the relation between the refractive indices of the two prisms and angle of prisms, relation between the angles of the prisms. So, if the two prisms are in a minimum deviation condition, at minimum deviation condition, we know that the angle of incidence and angle of emergence are equal, and angle of refraction inside will be equals to half the angle of the prisms. So, if I imagine that here the angles of the prisms are R1 and R2. So, I can say first of all, for first prism I1 should becomes equals to I2, I1 should be equals to E2, like E1 I can say, I1 is equals to E1. Now, because here this particular mirror is there, what happens is if you draw the normal with the horizontal, the angle made by the emergent ray from the first prism is E1. So, obviously what happens is the angle made by this ray with the normal to the prism will becomes equals to 90 minus E1. And similarly, angle of incidence and angle of reflection should be equal. Then what happens is the angle of reflection also will becomes equals to 90 minus E1. That means E1 is also equals to, when I1 and E1 are equal, then obviously what happens, so by symmetry I2 and E2 also should become equal. And according to the geometry of the question, geometry of the diagram, E1 and I2 are also equal. E2 is equals to I2, but I2 is equals to E2, because the second prism is also in minimum deviation condition. So, what we can do is for the first prism and second prism, what we can do is we can write the equation for the refraction. So, if you write on the equation for refraction, for first prism I can write 1 into sin I1 should becomes equals to N1 into sin R1. That should becomes N1 into, under minimum deviation condition R1 will becomes equals to A1 divided by 2, first one. Similarly, for second prism also I can write similar kind of equation, 1 into sin I2 is equals to N2 into sin R1 dash, that should becomes equals to N2 into sin R1 dash can be written as A2 divided by 2. Since I1 and I2 are equal, I can say N1 sin A1 divided by 2 is equals to N2 sin A2 divided by 2. So, from this equation I can say N1 divided by N1 into divided by N1 is equals to sin of A1 divided by 2 divided by sin of A2 divided by 2. So, the first option will be correct. Let us see the second option. If prism 2 is at minimum deviation condition, then sin I1 is equals to N2 sin A2 by 2 is always true. So, here only second prism is in minimum deviation condition. When second prism is in minimum deviation condition, what we can do is we can say I2 will becomes equals to E2, first one. And next point what we can say is, from this equation sin I2 should becomes equals to N2 into sin A2 divided by 2. This is the first equation. Now, once we got this one, what happens is by reflection, due to reflection at the plane mirror, what we can say is A2 and E1 will be equal. A2 and E1 will be equal, but E1 will not be equals to I1. So, we can say I2 should becomes equals to E1, but E1 is not equals to I1. So, when E1 is not equals to I1, then definitely this option B will be wrong. Next, option C. If both the prisms 1 and 2 are thin and are at minimum deviation condition with angles of deviation delta M1 and delta M2 respectively, then theta is equals to delta M1 divided by 2 into N1 minus 1 plus delta M2 divided by 2 into N2 minus 1. So, from the diagram we can see that the relation between theta A1 and A2 can be written as, first of all, when we consider deviation produced by the first prism, delta M1 will becomes equals to, the refractive index of this one is N1 minus 1 into the angle of prism is equals to A1. So, from this equation I can say, A1 will becomes equals to, pause, so right, A1 will becomes equals to delta minimum divided by N1 minus N2, N1 minus 1. Similarly, delta M2 is equals to N2 minus 1 into A2. This implies A2 will becomes equals to delta M2 whole divided by N2 minus 1. Here also is M1. Now, once we got A1 and A2 from the diagram, we can see that theta is equals to A1 divided by 2 plus A2 divided by 2. So, theta will becomes equals to delta M1 whole divided by 2 into N1 minus 1 plus delta M2 whole divided by 2 into N2 minus 1. So, from this option C should be correct. Look at option D. If prism 1 is in minimum deviation condition, sin I2 is equals to N1 into sin A1 plus 2, A1 by 2 is always true. Now, because the first prism is in minimum deviation condition, I can say I1 should becomes equals to E1. Of course, because of the reflection of the plane mirror, E1 should be also equals to I2. Now, applying Snell's law for the first prism, what I can say is sin I1 should becomes equals to N1 into sin R1, which is nothing but equals to A1 divided by 2 under minimum deviation condition. Because I1 and I2 are equal, I can say sin I2 should becomes equals to N1 into sin of A1 divided by 2. Hence, option D should be correct. Question number 6. In a vacuum chamber, a particle of charge 1 microcoulomb and mass 1 milligram is projected with a velocity I cap plus 2j cap meter per second. From xy plane, xz plane at time t equals 0 in electric field I cap volt per meter, t equals 0.2 seconds, the electric field is switched off and magnetic field of 6j Tesla is switched on. The acceleration due to gravity is minus 10 j cap meter per second square. Choose the correct option or options. The first option is they are asking what is the vertical distance of the particle from xz plane at time t equal to 0.3 seconds is. That is what we should calculate. So, let us see how to calculate this one. This is the vertical distance we should calculate. So, how do you calculate? Initially, what we will do is we will see how the particle will move up to 0.2 seconds where electric field is acting. So, for 0 less than or equals to t less than or equal to 0.2 seconds, initial velocity vector is I plus 2j meter per second. Then acceleration will becomes equals to, there will be two forces, one is force due to electric field, next one due to gravitational field whole divided by mass. So, acceleration is equals to q is given as 10 power minus 6 and electric field is given as I cap plus mass whole divided by mass can be written as 10 power minus 6 plus acceleration due to gravity is nothing but minus 10 j cap. So, acceleration vector will becomes equals to I minus 10 j cap meter per second square. We know initial velocity, we know acceleration vector. So, let us calculate the velocity at t equals to 0.2 seconds. At t equal to 0.2 seconds, velocity vector is equal to u bar plus a bar into t. That should becomes equals to u bar is I plus 2j, acceleration is nothing but I minus 10j, time is 0.2 seconds. So, velocity vector will becomes equals to, from this equation, 1.2 I cap meter per second. The j component will become 0. This is the velocity. So, at t equal to 0.2 second, at that moment the velocity is along x axis. After that, there is a magnetic field. The magnetic field is along j cap. So, when magnetic field is along j cap and then when the velocity is along I cap, then what happens is it will experience a force due to magnetic field perpendicular to both in the direction of v bar cross b bar I cross j, which is nothing but k cap. So, initially, so the particle will be moving in xz plane only due to magnetic field, and due to gravitational field what happens is it will be moving vertically downwards. So, the path is going to be a helical path. Path is helical. And then along the y-axis, the particle is moving only under the influence of gravitational force. So when you want to calculate the distance traveled up to t equals to 0.3 seconds, what we can do is we can use the formula. Initial velocity at t equals to 0 is 2 meter per second. Only acceleration along the vertical direction is minus 10. So if you want to calculate displacement along y-axis, what I can do is I can use the formula y is equal to uy. Initial velocity along y-axis is 2 into the time taken is 0.3 minus half into 10 into 0.2 whole square. So y is equals to 0.6 minus 5. This should becomes equals to 0.04. So this value will becomes equals to 5 into 0.04. This should be 0.3 up to 0.3 seconds. So 0.09. So 0.6 minus 0.45. This should become 0.15 meters, which is 15 centimeters. So option A should be right. Look at the second option. The vertical distance of the particle in xz plane at t equals 0.4 centimeters. Again, I can say y is equals to initial velocity along y direction is 2 into 0.4 minus half into 10 into 0.4 whole square. So y is equal to 0.8 minus 5 into 0.16. Y will become 0. So y is 0 means the particle is again coming back to xz plane. So this option B will be wrong. In the vacuum chamber, the radius of trajectory of the particle at t greater than 0.2 seconds. We saw that just at t equals 0.2 second, the particle is along x-axis, the velocity of the particle is along x-axis, and then the magnetic field is perpendicular to that one. So obviously the particle will be moving in a circular path due to the magnetic field, but because of gravity it will have helical path. So when we calculate the radius of the helix is given by m v perpendicular divided by qb. R is equals to mass is given as 1 milligram 10 to the power of minus 6. Velocity perpendicular at t equals 0.2 seconds. I have already calculated the velocity. At t equal to 0.2 seconds, we got the velocity as 1.2 meter per second. Charge is 1 micro into the value of magnetic field is given as 6. So R will becomes equal to 0.2 meters. This is the radius of helix. So here they given radius of trajectory of the particle. Radius of trajectory and radius of helix are different. So this, if this is radius of helix, then it should be correct. Otherwise, this option should be wrong. Next, the particle will be in xz plane at t equal to 0.35 seconds. So already I have calculated when it will be at a xz plane. So it is at 0.4 seconds. So this option also should be wrong. Let us move to the next question. Two charges q1 is equal to q and q2 equals to mq are placed at point p1 a comma b and p2 ma comma mb respectively in the xy plane, where a comma b is not equal to 0 and m is not equals to 0 or 1. If V1 is a potential at a point in xy plane due to charge q1 and V2 is a potential at a point due to charge q2, correct a statement or statements for which V1 is equals to V2 is R. So let us calculate what is the condition for V1 and V2 are equal. So here when V1 and V2 are equal, let us imagine that there is an arbitrary point P whose coordinates are x comma y. So V1, magnitude of V1 should becomes equals to magnitude of V2 implies KQ divided by R1 should becomes equals to K into MQ is the second charge divided by R2. So, k will get cancelled, q will get cancelled. From this equation we are going to get R2 is equals to mR1. So, relation between R1 and R2 is R2 equals to mR1. So, now from this equation we can say, if I consider that Px comma y is an arbitrary point, since we got R2 equals to mR1, this will implies R2 square is equals to m square R1 square. So, from this equation, the R2 is nothing but it is the distance of a point Px comma y from MA comma MB. So, R2 square can be written as x minus MA whole square plus y minus MB whole square is equals to m square into R1 square is nothing but x minus a whole square plus y minus b whole square. Now, from this equation, an expansion of this equation we are going to get x square plus m square a square minus 2m ax plus y square plus m square b square minus 2m by should becomes equals to m square x square plus m square a square minus 2m square ax plus m square y square plus m square b square minus 2m square by. Let us cancel the common terms on both the sides. M square a square will get cancelled, m square b square and m square b square will get cancelled. We will bring all the terms to one side. When I bring all the terms to one side, we are going to get this equation as m square minus 1 into x square plus m square minus 1 into y square. Similarly, bringing the other terms also to the other side, we are going to get minus, I will take minus 2m ax if I take common 1 minus x minus 2m by into 1 minus m should becomes equal to 0. This is also m. So, here 1 minus m can be taken as a minus I have taken common. When I have taken minus common, this will become so m minus 1, or else here it will become plus 1 minus m. I will change it. This is 1 minus m minus 1, because I have taken minus common. M minus 1 is taken common from all the terms, they will get cancelled. So, the equation implies m plus 1 into x square plus m plus 1 into y square minus 2m ax minus 2m by equal to 0. This equation will satisfy all the points for any arbitrary value of m for which v1 is equals to v2. Now, here they are given m is equals to minus 1. So, if m is equals to minus 1, the first two terms will become 0, the coefficients will become 0. Then we are going to get ax plus by will becomes equal to 0, which will represent a straight line. So, this option here will be correct. Let us see the other options. The general equation what we got is m plus 1 x square plus m plus 1 y square minus 2m ax minus 2m by equal to 0. So, in the second option they given m is equals to 2. When m is equals to 2, the equation will becomes 3x square plus 3y square minus 4ax minus 4by will becomes equal to 0. Converting this one into standard form of the circle equation, x square plus y square minus 4a divided by 3 into x minus 4b divided by 3 into y will becomes equal to 0. So, this equation in the form of x square plus y square plus 2gx plus 2fy plus c equal to 0. The center, the coordinates of the center will becomes equals to 2a by 3 comma 2b by 3, and the radius of the circle will becomes equals to under root of 2a by 3 whole square plus 2b by 3 whole square, which will becomes equals to 2 by 3 into root of a square plus b square. So, option B will be correct. Coming to option C, here they given m is equals to minus 2. Again we will write the equation of the circle, general equation, m plus 1 into x square plus m plus 1 into y square minus 2m ax minus 2m by is equal to 0. They given m is equals to minus 2. Substituting m is equals to minus 2, we are going to get this equation as minus x square minus y square plus 4ax plus 4by is equal to 0, x square plus y square minus 4ax minus 4by is equal to 0. This will also represent a circle whose center is 2a comma 2b and radius is equals 2 into root of a square plus b square. Option C is correct. Option D, m is equals to minus 3. So, again I will write the equation of this general equation. The general equation is m plus 1 into x square plus m plus 1 into y square minus 2m ax minus 2m by is equal to 0. M is taken as minus 3. So, minus 2x square minus 2y square plus 6ax plus 6by is equal to 0. So, from this equation I can write down x square plus y square minus 3ax minus 3by is equal to 0. So, from this equation we can see that this equation locus of the points is not a straight line, but it is a circle. So, option D will be wrong. Let us go to the next question. Consider an electric dipole comprising two charges plus q and minus q each with mass m separated by a fixed distance d and initially at rest with its dipole moment along I cap. A uniform electric field Ej cap is turned on at time t equal to 0 and it is turned off at t equals to Tf. When the dipole moment makes an angle theta f with I cap, neglecting any source of energy loss, correct option or option C is dash. First option says the center of mass of the dipole is deflected towards j cap in the presence of field. So, when we see these options, because they are given the direction of electric field is along I cap, the dipole is along I cap. So, that means here we have charge plus q, here we have charge plus minus q and plus q like this, and electric field is along y axis. The center of mass is deflected by towards. So, what happens is whether I consider this position or deflected position, always the positive charge and negative charge will experience equal forces in opposite direction. So, whenever we place a dipole in a uniform electric field, the net force acting on the dipole will become 0. When net force is 0, if it is initially at rest, it will be at rest. So, option A will be wrong. Let us look at the option B. So, the option B, if the magnitude of the final angular velocity is omega f is equals to root of 2q e divided by md, then theta f is equals to pi divided by 6. So, why will a dipole will be rotating in this? So, here if you look at the earlier diagram once again, this dipole will not experience any force, but it will experience what? Torque. So, what will this torque will do? It will change the orientation of the dipole, the angle between dipole and electric field will keep on changing, thereby the potential energy will change and obviously the kinetic energy also will be changing. So, as it rotates, there will be the total potential energy plus kinetic energy will remain constant. So, he says that the center of mass, the next one, if the magnitude of the final angular velocity is omega f is equals to root of 2q e divided by md, then theta f is equals to pi by 6. So, what we will do is we will apply conservation of the mechanical energy. So, when I apply conservation of mechanical energy, initially This is the direction of dipole moment, this is the direction of electric field. The angle between these two is 90 degrees. Initial angular velocity is 0. So, initial kinetic energy is 0 and initial potential energy is given by P bar dot E bar, that also will becomes equals to what? 0. And let us imagine that it has rotated when the dipole makes an angle theta f with I cap, they said. So, when it makes an angle theta f with the I cap, finally this is the direction of I cap, this is the direction of electric field, this is the direction of dipole moment, this angle is equals to theta. So, angle between electric field and dipole moment will becomes equals to 90 minus theta. So, at this moment let us imagine that the angular velocity of the dipole is equals to omega. So, what I can say is initial potential energy plus initial kinetic energy should becomes equals to final potential energy plus final kinetic energy. Initial potential energy, because the angle between dipole moment and electric field is 90 degrees, initial potential energy is 0, initial kinetic energy is also 0. Final potential energy will becomes equals to minus P into E into cos of angle between the electric field and dipole moment, that is nothing but 90 minus theta, plus kinetic energy will becomes equals to half I omega square. So, from this equation I can say half I omega square will becomes equals to P E sin theta. Okay. Half into the moment of inertia. The moment of inertia of the dipole is, there are two particles, mass of each particle is m, the distance of each particle from center is d by 2 whole square into omega square will becomes equals to P E sin theta. I can replace P also here. I can write dipole moment as Q is the charge and distance is d into E into sin theta. Now, from this equation m d square omega square divided by 4 should becomes equals to Q d E sin theta. So, d and d will get cancelled. So, from this equation we can get a relation between omega and sin theta. So, omega will becomes equals to under root of 4 Q E sin theta whole divided by m d. This is angular velocity. Now, here omega is given, you are asked to find out the value of theta. So, I can substitute the value of theta and I can find out the value of omega, or else I can substitute the value of omega also. So, look at this one. We got omega equals to under root of 4 Q E sin theta whole divided by m d. According to the question in the option, they given the value of omega is equals to under root of 2 Q E divided by m d. So, 2 Q E divided by m d should becomes equals to 4 Q E sin theta divided by m d. Cancelling all the common terms, we get sin theta equals to 1 by 2, theta will becomes equals to pi by 6, theta equals pi by 6. So, option B will be correct. Let us see option C. If theta f is equals to pi by 3, the change in kinetic energy of the dipole is given by, so change in kinetic energy, initial kinetic energy is 0, change in kinetic energy will becomes equals to final kinetic energy, that should becomes equals to the final potential, magnitude of final potential energy, which is nothing but P E sin theta. P is nothing but Q into D into E sin pi by 3, which is nothing but root 3 by 2 Q D E. So, option C will be wrong. Look at option D. Consider an electric dipole comprising, now here she said that if theta f is equals to pi by 4, the dipole rotates around its center of mass with a constant angular velocity after t greater than Tf. So, if theta equals to pi divided by 4, when t is greater than Tf, what is Tf here? It is the a uniform electric field E j cap is turned out at t equals to 0 and turned off at t equals to Tf. So, now they are saying that when t is greater than Tf, then what happens? So, obviously, because the electric field is switched off, torque for t greater than Tf, the torque is equal to 0. When torque is 0, omega will remain constant. Hence, option D also will be correct. Okay. Surpass. Your next question. 10 moles of an ideal gas initially in state A at atmospheric pressure and temperature T naught is equals to 27 degrees centigrade is enclosed in a metal cylinder of volume V naught fitted with a frictionless piston. The gas is suddenly compressed to state B with a volume V naught divided by 3. Now, keeping the piston stationary, the cylinder is submerged in a water bath of temperature 11 degrees centigrade until the gas reaches the temperature of the water bath, which is denoted as state C. Finally, while still in water bath, the piston is brought slowly to its initial position, which is denoted as state F. If R is universal gas constant, then the correct option or options is given that 9 to the power of 1 by 3 is equals to 2.08. So, if you look at the options, the first option says the schematic PV diagram of the process described by. So, here already they are given that there is a monatomic gas initiated in state A at atmospheric pressure and temperature T naught equals to 27 degrees centigrade, is enclosed in a metal cylinder and the gas is suddenly compressed. So, when it is suddenly compressed, we can say from A to B it is a sudden process. So, when it is a sudden process, because volume is decreased, it should be an adiabatic compression. Next, till the volume becomes V naught divided by 3. Now, keeping the piston stationary. So, when the piston is kept stationary, the volume of the cylinder will remain constant and then the temperature is changed. So, when the temperature is changed from 27 degrees centigrade to 11 degrees centigrade, it is changed from state B to C. So, B to C is an isochoric process. Cooling. And after that, he says that finally, while kept still in the water bath, the piston is brought slowly to its initial position. So, what happens is C to F. During this process, what happens is slowly the temperature is going to be what? The temperature is kept constant and volume has increased to its initial volume. So, it is an isothermal process, isothermal expansion. Process. Because after the volume has changed to V naught by 3, it is kept, piston is kept stationary, the cylinder is submerged in a water bath of 11 degrees centigrade until the gas reaches the temperature of water bath. While still in water, it is brought back to slowly. So, temperature will remain constant. So, it is an isothermal process. Now, he is saying the schematic PV diagram of the process described above is. So, you can see from A to B it is adiabatic compression. So, it is adiabatic compression, volume is decreasing. So, pressure will increase obviously. So, the graph can be from A to B. From B to C it is isochoric cooling, volume should remain constant. So, when temperature is decreasing obviously pressure will decrease. So, from B to C pressure will decrease as well as temperature will decrease. And from C to F what is happening? It is an isothermal process. So, it is an isothermal process. During this process what is happening? Isothermal process and also the temperature is kept constant, the volume is increased. So, it is isothermal process, that too isothermal expansion we can say. So, volume is increased to initial state. Now, you can see that A and F are not same. Why A and F are not same? Because the initial temperature and final temperature are not same. Volumes are equal, but we can see that initial temperature is more than final temperature. So, obviously, initial pressure will be more than final pressure, that is why A and F will not merge here. Okay, so, option A will be correct. Next, option B. In the option B, they say the change in internal energy as going from state A to state B. So, from state A to state B, what is the change in internal energy? How do you calculate change in internal energy? So, to find out change in internal energy, we should know initial temperature and final temperature. Temperature at A we know, which is equals to 300 Kelvin. We need to find out temperature at B. AB is an it's an adiabatic process. So, you know initial volume, you know final volume, you know initial temperature, we need to calculate the final temperature. So, how do you calculate this one? Because it is an adiabatic process, TV power gamma minus 1 equal to constant. So, from this equation I can say TB Vb to the power of gamma minus 1 should becomes equals to Ta Va to the power of gamma minus 1. So, Tb will becomes equals to Ta into Va divided by Vb to the power of gamma minus 1. So, from this equation Ta we know 300 Kelvin, Va we know V naught, Vb we know V naught divided by 3. When it comes to gamma for a monoatomic gas, gamma is equals to 1 plus 2 divided by F, 2 divided by 3, that should becomes equals to 5 divided by 3, 5 by 3 minus 1 will become 2 by 3. So, temperature at B will becomes equals to 300 into volume at A is V naught by V naught by 3 is nothing but 3 to the power of 2 by 3. So, from this equation this 3 to the power of 2 by 3 is nothing but 9 to the power of 1 by 3. So, this value will becomes equals to 300 into 2.08. So, temperature at B will becomes equals to 624 Kelvin. So, the change in internal energy will becomes equals to NCV delta T. So, delta U will becomes equals to number of moles are given as 10. Because it is a monatomic gas, Cv is equals to 3 by 2 R into change in temperature is nothing but 624 minus initial temperature is 300. This should becomes equals to 10 into 3R by 2 into 324. This value will comes out to be 4860 R. So, option B will be correct. Next, option C. In the option C says the net change in internal energy in the whole process is. So, net change in internal energy means I can say again delta U is equals to NCV delta T, delta U equals to N, Cv is nothing but 3R by 2, delta T is nothing but temperature F minus temperature at A. That should becomes equals to 10 into 3R divided by 2 into the final temperature minus initial temperature. So, initial temperature at A is nothing but 300 Kelvin. Temperature at F is nothing but 11 degrees centigrade, which is 273 plus 11, that should becomes equals to 284 Kelvin. So, when I take the temperature difference, we are going to get this value as minus 16. So, when we got as minus 16, this will become 8 times. So, this should becomes equals to minus 240 R joules. So, option C also should be correct. And the last option, the pressure and temperature of the gas is 2.08 times the atmospheric pressure and 624 Kelvin respectively. So, the pressure and temperature of the state B, I think it should be state B, they should find out. Already we found the temperature at state B. Next one we have to calculate what? We have to calculate the pressure at state B. Because in an adiabatic process, Because it's an adiabatic process, what we can do is in the option D, we can get a relation between pressure and volume, PV to the power of gamma equal to constant. So, PB will becomes equals to PA into VA divided by VB whole to the power of gamma. That should becomes equals to PA into 3 to the power of, the value of gamma we got as 5 divided by 3. So, this should becomes equals to P naught into this 5 3 to the power of 5 by 3 can be written as 3 into 3 to the power of 2 by 3, that should becomes 3 into 2.08. So, this value will becomes equals to around, pressure at B will becomes equals to 6.24 P naught, which is not 2.02 times. So, option D will be wrong. So, option A, B and C are correct. Next question. Two thin wires, wire 1 of diameter 0.650 millimeter and wire 2 of unknown diameter D is given. To obtain the value of D, the diameters of the two wires are measured with screw gauge. The screw gauge has a pitch of 0.5 millimeters and there are 100 divisions on the circular scale. The smallest division on the linear scale is 0.5 millimeter. The table shows the readings of LS and CS for the measurement, that is circular scale and linear scale. The value of D in micrometers is dash. So, here the actual diameter of wire 1 is given. So, the actual diameter of wire 1, the true value is given 0.650. What about the measured value? To find out measured value, first of all we will consider least count. Least count is pitch divided by number of head scale divisions. Pitch of the screw is nothing but 0.5 millimeter by number of divisions is given as 100. So, the least count will becomes equal to 0.5 into 10 power minus 2 millimeter, that should becomes 0.05 millimeters. Now, once we got this one, the measured value of diameter of the first wire will becomes equals to, the measured value is equals to, according to the given table, for this one the linear scale value is nothing but 0.5 millimeter plus the circular scale reading is nothing but 42 into 0.005 millimeters. So, the value of D will becomes equals to 0.5 millimeters plus, when I multiply these two, we are going to get 0.42 into 0.5, which is nothing but 0.21. So, the diameter, measured diameter is equals to 0.71 millimeters. This 0.71 millimeter is differ from the actual value. So, it is showing a larger value. So, that means there is a positive error, there should be correction should be negative. So, error will becomes equals to 0.71 minus 0.650. So, error will becomes equals to, when I take the difference of these two, it should becomes equals to 0.06 millimeters. When error is positive, correction is negative, minus 0.06 millimeters. Now, using this correction, we have to find out the correct reading of the diameter of the second wire. So, when you want to find out the correct reading of the diameter of the second wire, we can find out like this. Diameter of the second wire is equals to 1.5 plus 95 into 0.005. So, diameter is equals to 1.5 millimeter, 95 into 0.005 is nothing but equals to 0. This should becomes equals to 0.95 into 5. 0.95 into 5 is nothing but 4.8. Sorry, 0.95, that should becomes equals to 0.475. So diameter should becomes equals to 1.975. This is a measured millimeters, this is a measured value. Once we got the measured value, then what we have to do, we have to make the correction. What is the correction? So correction is negative, which is equal to 0.06. So the correct value of the second diameter will becomes equals to 1.975 minus 0.06 millimeters. That should becomes equals to 1.915 millimeters. This should be the diameter of the second one. This is question number 10. Next, question number 11. In a single slit diffraction experiment, a slit of width 0.016 plus or minus 0.002 millimeter is used to measure the wavelength of a monochromatic light source. In diffraction pattern, the angular distance between the central maxima and the first minima is measured to be 2 degrees plus or minus 40 minutes. The value of fractional error in the measurement of wavelength is dash. So when you want to calculate a fractional error in the measurement of wavelength, because the angular position of first minima is given, the relation between angular position of first minima, wavelength and the width of the slit is given by lambda is equals to a sin theta. From this equation you can say d lambda by lambda is equals to dA by A plus cos theta divided by sin theta into d theta. D theta is the error in the measurement of the angle, dA is the error in the measurement of width of the slit, and then d lambda is the error in the measurement of wavelength. D lambda divided by lambda will give the error in the measurement of fractional error in the measurement of wavelength. So from this equation I can say delta lambda divided by lambda is equals to delta A by A plus cos theta divided by sin theta into delta theta. Now first let us calculate delta theta. According to the question, this delta theta is given as 40 minutes. That should becomes equals to 40 divided by 60 degrees, which is equals to 2 by 3 degrees. Now we need to convert this one into radians, which is nothing but 2 by 3 into pi divided by 180. So delta theta will becomes equals to pi divided by 270 radians. So delta lambda divided by lambda will becomes equals to delta A 0.002 divided by A is 0.016. Cos theta, here cos 2 degrees, 2 degrees is very small, sin 2 degrees is given as 0.035, it is very small. So when theta is very small, cos theta is approximately equals to 1. So 1 divided by sin 2 degrees is nothing but 0.035 into delta theta. Delta theta is nothing but pi divided by 270. Now when it comes to the value of pi, it is 3.14. On evaluation of this one, delta lambda by lambda, we are going to get this one as 0.457. This is a fractional error. So it should be, range should be given around 0.45 to 0.46. The next question. As shown in the figure, a ray AB of unpolarized light enters from water of refractive index 4 by 3 into a medium of refractive index 4 divided by root 3. After passing through the glass plate of refractive index Ng is equals to 4 by 3 and a layer of water. At a particular angle of incidence I, the reflected ray CD is polarized in a direction as shown in the figure. So if the CD should be completely polarized, at the point of reflection, the angle of incidence should be the Brewster's angle. Now here, because they are given this refractive index of, alternatively we have water, glass and water. If angle of incidence is I, angle of refraction is R. At this point angle of refraction also will become R. When it goes into again water medium, here the angle will become I. The other angle also will becomes equals to I. So at the point where the ray is getting reflected between water and other medium of refractive index 4 divided by root 3, this I should be the Brewster's angle. That means the angle between refracted ray and reflected ray, this angle should becomes equals to 90 degrees. So applying a Snell's law at point P, what happens is, at point P, 4 divided by 3 into sin I should becomes equals to 4 divided by root 3 into the angle of refraction there will becomes equals to 90 minus I. So 4 and 4 will get cancelled. Sin I whole divided by 3 is equals to cos I divided by root 3. Tan I is equals to root 3. This implies I will becomes equal to 60 degrees. This should be the angle of incidence I. Next question. As shown in the figure, the resistance of the galvanometer G can be found by half deflection method. Hence, the resistance R2 is adjusted such that when the key K is closed, the deflection of the galvanometer becomes half of the value as compared to when K is open. Half deflection is obtained at R2 is equals to 4 ohms, and thus the galvanometer resistance is found to be 6 ohms. In this half deflection condition, the current in milliamperes through R1 is dash. So just pause. So here this is the arrangement where this method is called as half deflection method to find out resistance of the galvanometer. So here I will consider two different situations. Situation 1, case 1, when the key K is open, case 2 when key K is closed. So when K is open, the current in the circuit will becomes equals to total EMF 10 divided by total resistance. The total resistance, the resistance of galvanometer is given 6 ohms, R1 is not given. So R1 plus the resistance of the galvanometer is 6. This is the current flowing through the galvanometer also. Now next when K is closed, if K is closed. So when K is closed, what happens is the resistances R2 and galvanometer both will be parallel, and for that R1 is connected in series. So the total current in the circuit will becomes equals to 10 whole divided by R1 is the resistance connected. This is connected in series to the effective resistance of G and R2. So G value is given as 6 and R2 is given as 4. So 6 into 4 divided by 6 plus 4. I will call this current as I dash. So I dash will becomes equals to 10 whole divided by R1 plus 24 divided by 10 is nothing but 2.4. This is the total current in the circuit after the switch K is closed. This is the total current when K is open. Now I need to calculate the current through the galvanometer. So how do we find out the current through galvanometer? Between these 2 points P and Q, the resistance R2 and galvanometer are connected in parallel. So the reading through galvanometer, I can call it as the reading through galvanometer is Ig will becomes equals to, because their parallel potential differences will be equal. When potential differences are equal, I can say Ig divided by resistance through galvanometer. The fraction of the current that is flowing through galvanometer will becomes equals to resistance is equals to R2. So I can say Ig divided by the current through the galvanometer, the current through resistance R2 is nothing but I dash minus Ig should becomes equals to the product of the ratio of the resistances. R2 is given as 4 and G is given as a 6. Okay. This should becomes equals to 2 by 3. So now from this equation I can say 3ig should becomes equals to 2i dash minus 2ig. So, ig should becomes equals to 2i dash divided by 5. That should becomes equals to, when I take 2 by 5 of this one, 4 divided by R1 plus 2.4. This is the new current through galvanometer. Earlier the current through galvanometer is nothing but 10 divided by R1 plus 6. According to the question, Ig is equals to I divided by 2. Ig is equals to I divided by 2. So, the value of Ig we got as 4 divided by R1 plus 2.4. I divided by 2 is nothing but 1 by 2 into 10 divided by R1 plus 6. So, from this equation we are going to get 8R1 plus 48 should becomes equals to 10R1 plus 24. So, 2R1 should becomes equals to 24, R1 should becomes equals to 12 ohms. We got a value of R1 as 12 ohms. Now, he says that thus the galvanometer resistance is found to be 6 ohms. In this half deflection condition, the current through R1 is, what is the current through R1 in half deflection condition? So, in half deflection condition, the current through galvanometer is nothing but, I have already calculated the formula for this one, I dash is equals to 10 divided by R1 plus 2.4. So, I should becomes equals to 10 divided by R1 we got as 12 plus 2.4, that should becomes 10 divided by 14.4. So, this value is we are going to get this value as around 0.6944 amperes. So, when we convert this one into milliamperes, we are going to get, because they have asked in milliamperes, 694.44 milliamperes. This is going to be the current. The next question. In a new system of units, the units of mass, length, time and current are 5 kg, 5 meter, 5 seconds and 5 amperes respectively. If mu naught and epsilon naught are the permeability and permittivity of free space respectively, then in the new system of unit, the magnitude of SI unit of root mu naught by epsilon naught is dash. So, when you want to calculate the unit of root mu naught divided by epsilon naught, I will simplify this equation as I will multiply both numerator and denominator with epsilon naught. So, root of mu naught epsilon naught whole divided by epsilon naught. Root of mu naught epsilon naught is nothing but 1 divided by c. So, this value is nothing but 1 divided by c into epsilon naught. This is the quantity x. First, what we do is we will write down the dimensional formula for this. So, how do you write down the dimensional formula for this? The dimensional formula for c, speed of light, is nothing but Lt power minus 1. The dimensional formula for epsilon naught is nothing but equals to the dimensional formula for q whole square divided by the dimensional formula for force into r square using Coulomb's law. So, the dimensional formula for epsilon naught will becomes equals to q can be written as current into time It whole square divided by F into R square. So, from this equation I can say current is nothing but A T square whole divided by force is nothing but M L T power minus 2 into L square. So, the dimensional formula for 1 by epsilon naught we can write directly, should becomes equals to M L cube T power minus 4, here also A square will get square of this one. So, A to the power of minus 2. So, the dimensional formula of quantity x is nothing but 1 divided by c is nothing but Lt power minus 1 and 1 by epsilon naught dimensional formula we got as m L cube T power minus 4 a to the power of minus 2. The dimensional formula for x will becomes equals to m L square T power minus 3 a to the power of minus 2. This is a dimensional formula for x. Once we got a dimensional formula for x, I can say let n1 SI units should becomes equals to n2 new units. So, n1 kg meter square second to the power of minus 3 ampere to the power of minus 2 is equals to n2. In place of kg should be 5 kg. In place of meter should be 5 meter. In place of second it should be 5 second. In place of ampere it should be 5 ampere. Okay. Kg meter square second power minus 3 a square a power minus 2 will get cancelled. So, n1 will becomes equals to, here we have 5 into 5 square 5 power 3 5 power minus 3 will get cancelled. You are going to get this n1 is equals to n2 divided by 25. So, from this equation I can say this implies n2 should becomes equals to 25 n1. So, I can say n1 SI units is equals to n2 new units. They are asking the magnitude of 1 SI unit is. So, substituting the value of n2 we can say 1 SI unit should becomes equals to 25 new units. So, the answer should be 25. Next question. Next we will go into the passage questions. Sir, the last section, questions. So, the passage, the stem of the question says that a container of height 2 meters, length 2 meters and breadth 1 meter is made of insulating vertical walls and two large area horizontal metal plates M1 and M2, which extends far beyond the vertical walls in all directions. The container is partitioned into two equal chambers with thin insulating vertical walls. The partition wall contains a small hole of cross-sectional area √10 centimeter square near its bottom. Initially the hole is closed and the left chamber of the container is completely filled with a liquid of dielectric constant epsilon r equals to 15, and the right chamber is empty epsilon r equals to 1. At time t equal to 0, the hole is opened and the liquid flows from the left chamber to the right chamber. In both the chamber, the space above the liquid has epsilon r equals to 1 and is maintained at atmospheric pressure. The schematic of the container at time t greater than 0 is shown in the figure. Given acceleration due to gravity is 10 meter per second square. The first question is the height of the liquid in the left chamber at t equals to 500 seconds is dash. So, initially the total liquid is in the left chamber. So, question number 15, the height in meter of the liquid in the chamber, left chamber at t equals to 500 seconds is dash. So, here the liquid is flowing from left chamber to right chamber through an orifice arranged at the bottom, at the partition of the two chambers. So, what we will consider is at an instant of time t, I will imagine that the height of the liquid in the left chamber, right chamber is h, such that the height of the liquid in the left chamber will becomes equals to 2 minus h. The velocity of efflux from left chamber to right chamber is equals to v. The pressure of air atmosphere above this one is equals to P naught. So, at the bottommost point in the left chamber and right chamber, these 2 points are 1 and 2. At those 2 points, when we apply the Bernoulli's principle, we are going to get on the left side the total energy per unit volume will becomes equals to P naught plus rho g into 2 minus h and because it is a white chamber, the kinetic energy is approximately 0, so plus 0. On the right chamber, it should becomes equals to P naught plus rho g h plus half rho v square. P naught will get cancelled on both the sides. So, from this equation we are going to get half rho v square will becomes equals to rho g into 2 minus 2h. Rho also will get cancelled on both the sides. V will becomes equals to under root of 2g into 2 minus 2h. V will becomes equals to 2 into root of g into 1 minus h. When the height of the liquid in the right chamber is h, the velocity with which the fluid enters to right chamber is 2 into root of g into 1 minus h. At this moment, the rate at which the fluid is entering to the right chamber is equals to rate at which volume of the liquid in the right chamber is varying. So, rate of flow will be given by Q is equals to AV, that should becomes equals to capital A into dH divided by dt. So, small a into V is nothing but 2 into root of G into 1 minus H is equals to capital A into dH divided by dt. Separating the variables, dH divided by root of 1 minus H should becomes equals to 2 small a divided by capital A into root G into dt. Now, let us integrate this equation on both the sides. When you integrate this equation on both the sides, integral dH divided by root of 1 minus H is equals to 2 small a by capital A into root G into integral dt. At t equal to 0, the height of the liquid in the right chamber is 0. At time t, the height of the liquid in the right chamber is equals to h. Now, when it comes to left hand side integral, this is something like a root dx divided by integral dx divided by root x form. So, the integration of this one will becomes equals to 1 minus h whole to the power of 1 by 2, that is root whole divided by minus 1 by 2. So, 2 goes to numerator with a minus sign, denominator 1. So, here the limits are from 0 to h is equals to 2 small a by capital A into root g into t. So, when I apply the limits, we are going to get 2 into 1 minus root of 1 minus h under root should becomes equals to 2a divided by capital A into root g into t. So, now here the time is given, which is equal to 500 seconds. At that point, you are asked to find out the height. So, I will cancel here 2 and 2. So, substituting the values, 1 minus root of 1 minus h is equals to small a by capital A into root g into t. So, 1 minus root of 1 minus h is equals to, the value of small a is root 10 into 10 to the power of minus 4. Capital A is 1 meter by 1 meter, this side is 1 meter, inside depth is 1 meter. So, 1, root g is root 10 into time is 500 seconds. So, from this equation 1 minus root of 1 minus h is equals to root 10 into root 10 is 10. So, 5000 into 10 to the power of minus 4, which is nothing but 0.5. So, from this equation we are going to get root of 1 minus h is equal to 1 by 2. This implies 1 minus h is equals to 1 by 4, h is equals to 3 divided by 4, which is 0.75 meters. So, at 500 seconds, the height of the liquid in the right chamber is 0.75 meters. They have asked the height of the liquid in left chamber. In left chamber, the height will becomes equals to 2 minus 0.75, which is nothing but 1.25 meters. This should be the answer for question number 15. Question number 16. The difference in capacitance between the metal plates at t equal to 0 and t equals to 500 seconds is 8 minus n epsilon naught. Here epsilon naught is permittivity of free space, the value of n is a dash. So, how do you find out this one? Initially, the liquid, what happens is there is three parts which we can consider. One is the part outside the two chambers, okay, that is having some initial capacitance that won't change, only capacitance inside the chambers only will change. So, initially the meaning of initially is at time t equal to 0, the left chamber is completely filled with a liquid and right chamber is completely filled with air. So, between the two metallic plates, those two capacitances, if they are C1 and C2, they are connected in parallel. So, the effective capacitance, initial capacitance will become C equals to, capacitance of the left portion will become C equals to 15 is the dielectric constant, epsilon naught, area is 1 divided by distance will become 2, plus capacitance of the right chamber will become C equals to is filled with air. So, epsilon naught into area is 1 divided by 2. So, C1 will become C equals to 8 epsilon naught. This is initial capacitance. This is at time t equal to 0. Now, at time t equals to 500 seconds, what happens is this height, this is 0.75 meters and this height is 1.25 meters. The remaining height here, this is 1.25 meters and this height is 0.75 meters. The capacitance of this portion is C1, the capacitance of this portion is C2, the capacitance of this portion is C3, the capacitance of this portion will become C4. So, what happens is between the plates C1 and C2 are in series, C3 and C4 are in series and all these combinations will be in parallel. So, when you find out the capacitance, effective capacitance at t equals to 500 seconds, then first of all let us calculate effective capacitance of left chamber and right chamber separately. Because the C1 and C2 are connected in series, the effective capacitance will become C equals to 1 divided by C12 will become C equals to 1 divided by C1 plus 1 divided by C2, 1 divided by C12 will become C equals to, the distance will become C equals to, it's like 1.25. So, 1.25 whole divided by 15 into epsilon naught is the permittivity into area will become C equals to 1 into 1 will become 1 plus 1 divided by C2 will become C equals to 0.75 divided by 1 into epsilon naught. Now, from this equation we can say 1 divided by C12 will become C equals to 15 epsilon naught 1.25 plus 0.75 into 15. So, C12 will become C equals to 15 epsilon naught whole divided by 1.25 plus 0.275 into 15. This is the effective capacitance between the portions of the left chamber. Similarly, capacitance between the portions of a right chamber will become C equals to C2 C34 will become C equals to 1 by C34 is equals to 1 by C3 plus 1 by C4. This is C3, this will become C4. 1 by C34 will become C equals to 15 epsilon naught, area is 1 and distance is 0.75. So, 0.75 divided by 15 epsilon naught plus 1.25 divided by epsilon naught. Again here also 15 epsilon naught 0.75 plus 1.25 into 15. C34 will become C equals to 15 epsilon naught whole divided by 0.75 plus 1.25 into 5. This is C34. Now we understood that C1, C2 are in series, C3, C4 are in series, those combinations will be parallel. So the effective final capacitance will become C equals to C12 plus C34. That should become C equals to 15 epsilon naught. If you take common, 1 divided by the earlier value plus 1 divided by 0.75 plus 1.25 into 5, 15 into 15. So on the calculation of this final capacitance, this value you are going to, after calculation we are going to get this value as 128 divided by 65 epsilon naught. They have asked what is the initial capacitance minus final capacitance. So initial capacitance minus final capacitance, when we calculate, we are going to get this value as, and this value is equals to 1.97 epsilon naught. So when I find out initial capacitance minus final capacitance, it should become 8 minus 1.97 epsilon naught. So the value of n is equals to 1.97 is the value of n. The next passage. A uniform circular disc of radius 0.2 meters and mass 1 kg is pivoted at its top point C such that it can rotate freely around C in the xy plane as shown in the figure. Initially, when the disc is at rest, a particle of mass 20 gram traveling along the negative x direction in the xy plane with speed of 100 meter per second hits the circumference of the disc at the point P. Initially, the collision of the particle after collision, the particle moves along the y direction at a speed of 90 meter per second. Given acceleration due to gravity as minus 10 j cap meter per second square, the questions are, after collision the disc starts rotating about a point C in xy plane, the maximum change in the height of the center of the disc O is, and amount of energy loss in joules is dash. So let us see how to calculate this one. So first we will calculate what is the maximum height rise. So what can happen about the point C, we can apply law of conservation of angular momentum. So this is the direction in which initially the particle is rotating. Just after collision, let us imagine that the angular velocity of the disc about point C is equal to C. So what we can do is we can apply law of conservation of angular momentum about the point C. Just before collision and just after collision, torque is 0. So we can say initial angular momentum is equals to final angular momentum. So what is the final angular momentum is equals to? The angular momentum of the disc about point C is nothing but m r square by 2 plus m r square, which is nothing but 3 by 2 m r square into omega plus the angular momentum of the particle after collision. This is in anti-clockwise direction. The particle was moving after collision like this. This is the path. This is the direction. This is also like clockwise, sorry. So this is also clockwise. Both are in clockwise direction. So the angular momentum after collision for the particle will become C equals to m. The final velocity into perpendicular distance will become C equals to r divided by root 2 is equal to initial angular momentum is equals to mu into the perpendicular distance from point C will become C equals to r plus r divided by root 2. So now from this equation I can say 3 by 2 capital M r square omega should become C equals to, when I take this term to right hand side, m I can take common, r I can take common, u into 1 plus 1 divided by root 2 minus v divided by root 2. So 3 divided by 2 into the mass of the disc is given as 1 kg. The radius of the disc is given as 0.2 meters into omega equals to The mass of the particle is given as 20 grams, 20 into 10 to the power of minus 3. R value is again 0.2. Initial velocity is given as 100. 1 plus 1 divided by root 2, that is root 2 divided by 2, which is 0.707, minus V, final velocity is given as 90 into 0.707. Now from this equation, 0.2 will get cancelled. Now from this equation, when we calculate the value of omega, so the value of omega when we calculate, we are going to get this value as 7.138 radian per second. This is the angular velocity of the disk just after collision. So just after collision, what happens? It will start rotating with this angular velocity. So the particle will be, the disk will be raised. Initially it will have rotational kinetic energy, finally it will have a potential energy. As it goes up, potential energy will increase, kinetic energy will decrease. So applying law of conservation of energy, what we can say is the decrease in rotational kinetic energy is equals to increase in potential energy. So applying law of conservation of energy, let us imagine that height raised is h. So mgh is equals to the decrease in the rotational kinetic energy is nothing but half I omega square. So from this equation, m, capital M is given, which is nothing but 1, g value is given as 10 into the value of height is equal to h, 1 by 2 into moment of inertia is nothing but 3 by 2 into m, r is 0.2 whole square into omega square, 7.138 whole square. On simplifying this, the height of the liquid, the height of the center of the disk through which it rises is equals to 0.152 meters. When you round it off to 2 digits, it should be 0.15 meters. The next question. The amount of energy loss in joules is. So here, how much energy is lost? So if you want to find out loss in energy, it should be equals to the total initial kinetic energy minus final kinetic energy. So loss in energy is equal to total initial energy minus final energy. Initially only the particle was moving, half small m u square, minus the final energy is nothing but half small m v square plus 1 by 2 into I into omega square. Half I omega square is the rotational kinetic energy just after collision. So now from this equation I can say half into small m is nothing but 20 into 10 to the power of minus 3, initial velocity is 100 whole square, minus of half into small m again is 20 into 10 to the power of minus 3 into the final velocity is given as 90 whole square plus half into moment of inertia about point C is 3 by 2 mr square, mass of the disk is m and radius of the disk is 20 centimeters, 0.2 whole square into omega square. The value of omega we got 7.318 whole square. So on simplification of this, we are going to get the loss in kinetic energy is equals to 17.47 joules. A range should be given between 17.45 to 17.50 joules. Thank you.